in part A of this exam question, we have to differentiate 4x cubed minus x to the power of 4. So remember, when you're differentiating, you have to take the power on the x, so here we have 3, and you multiply this power by the number here at the front. So 3 multiplied by 4 is 12, and remember the power on the x decreases by 1. So 3 take away 1 is 2, so we have 12x squared. Next we have minus x to the power of 4, which is the same thing as minus 1x to the power of 4. So if we use the same method and differentiate, we take the power of 4, we multiply it by this number here, so 4 multiplied by negative 1 is negative 4, and again the power on the x decreases by 1, so 4 take away 1 is 3. Okay, so we have x cubed. Okay, so we've done part A, we've differentiated. Now, in part B, we have to find the coordinates of B, and you can see from the diagram here that point B is a maximum point on the curve. Remember, at a maximum or a minimum point, the gradient is always equal to 0, okay? So in part A, when we differentiated, notice how this is from the equation of our curve. When we differentiated this, what we were doing is we were finding an expression for the gradient of the curve at any point, okay? So what we can do here in part B is put our expression for the gradient equal to 0, okay? Because remember, the gradient at point B is 0, okay? So that's my first step. So this gradient that we just worked out is equal to 0. So if we're working out the coordinates of B, it means we have to work out the value of x and y for the coordinates. Here I have an equation in x. So what I'm going to do is I'm going to solve this equation for x, and that will give me the x coordinate of B to begin with, okay? So when I'm solving this equation, what I'm going to do is I'm going to factorize the left-hand side of this equation. So when I factorize, I would have 4x squared outside the brackets. And so inside the brackets here, I would have 3 minus x, okay? So the first step here is just factorizing. So there are two values of x. Either this part is equal to 0, which means x has to equal 0, or the bracket here is equal to 0. And if this bracket is equal to 0, this value of x has to be 3, because 3 take away 3 is 0. So our second value of x is 3. Okay, so there are two values of x, okay, but we only need one. So let's just look back at the diagram. X equal to 0 is here. Okay, so we're not interested in this point here. We're interested in when x is equal to positive 3, okay, the x coordinate of point B. Okay, so there's our first part. X is equal to 3. So in order to find the coordinates, we also have to work out the value of y. So what you have to do is use your value of x and substitute this back into the original equation here, okay? So I'm just going to write down the equation. So we've got y equals 4x cubed minus x to the 4. And we just worked out the value of x was equal to 3. So you're going to replace your x values with 3. So we have 4 brackets 3 cubed minus 3 raised to the power of 4, okay? So if we work this out, it's the same thing as 4 multiplied by 3 cubed, which is 27. And 3 to the power of 4, which is 81. And then if you calculate 4 multiplied by 27, take away 81, you should find that it's 27. And remember, this, what we just worked out, is the value of y. Okay, so when you write your final answer, just summarize, the coordinates of B would be 3, 27. Remember, the x coordinate always goes first, followed by the y. In part C, we have to find the gradient of the graph at point A. And you can see from the diagram that point A is just here. It's where the curve intersects the x-axis, okay? Remember earlier on, I said when we differentiate, what we're doing is we're finding an expression for the gradient of the curve at any point. So this here is the gradient of the curve. And if we want to find the gradient of a specific point, i.e. at point A, we need to know the x-coordinate at point A first, okay? So if we look again at the diagram, you can see that Point A is when the curve intersects the x-axis, which means the y value here has to be equal to 0. Okay, whenever the curve intersects the x-axis, the y value is always equal to 0. Okay, all the way along here. So we can use this information by substituting the value of y back into the original equation here, and then we can solve that to find the x value at point A. Okay, so y is equal to 0. Okay, and so if I replace it in this equation here, I would have 0 equals 4x cubed minus x to the power of 4. Then if I want to solve this equation, what I'm going to do is I'm going to factorize the right-hand side. So in front of the brackets, I would have x cubed, and inside the brackets, 4 minus x. Okay, so if this equation is true, either this value here is equal to 0, so x is equal to 0, or this bracket is equal to 0. And if that's the case, then x should be 4, because 4 take away 4 is equal to 0. Okay, so either x is equal to 0 or x is equal to 4. So we have two values because you can see the curve also intersects the x-axis here at the origin. Okay, so that's the first value of x. So the value of x at point A has to equal 4. Okay, so we have our x value. Now we can go back to our gradient here and substitute 4 into here and here. Okay, remember this is the gradient of the curve at any point. So we have 12 brackets 4 squared minus 4 and then 4 again, all cubed. Okay, so now if I work this out, it's like saying 12 multiplied by 4 squared minus 4 multiplied by 4 cubed, which is equal to negative 64. Okay, and so that is the gradient at point A. In part A of this exam question, we have to find the coordinates of points A, B and C. We can see from the diagram that points A and C are where the curve intersects the x-axis, and point B is where the curve intersects the y-axis. I'm going to start by finding the coordinates of point B. Okay, so this is where the graph intersects the y-axis. So at that point, the value of x has to equal 0. Okay, whenever a graph intersects the y-axis, the x value will always equal 0. Okay, so we first found the x coordinate here of point B. So using this value, we can then find the corresponding y value. All you have to do is replace x with 0 in the equation of the curve. Okay, so instead of having y equals 18 plus 5x and so on, we've got y equals 18 plus 5 lots of 0 minus 2 lots of 0 squared. Okay, so you're just replacing any x value in the equation with 0. Now remember, anything multiplied by 0 is 0, so 5 multiplied by 0 is 0, negative 2 multiplied by 0 squared is 0, so the value of y is 18 at point B. Okay, so there's point B. Now if we look at points A and C, okay, so where the graph intersects the x-axis, this time we know that the y value is equal to 0. Okay, so whenever a graph intersects the x-axis, the y value always equals 0. Okay, and we're going to use the same idea. We're just going to replace the y value with 0 in the equation of the curve and then solve for x. Okay, so instead of y equals, we have 0 equals 18 plus 5x minus 2x squared, and now we have to solve this quadratic equation. Okay, I'm just going to reverse the signs here so that I have positive 2x squared instead, negative 5x, negative 18. I just think it's simpler to work with. Okay, so we're solving this quadratic. You can either use the quadratic formula, or if you like, you could factorize like me. Okay, so if you're factorizing this one, so popping it into brackets, it should be 2x minus 9 and x plus 2 in the other bracket. If you're not sure how to factorize a quadratic like this, do have a look at my other lesson on PAF, P-A-F, okay? It will show you how to factorize quadratics like this, okay? So if this is equal to 0, either this bracket is equal to 0 or this bracket is equal to 0. So if the first bracket, 2x minus 9, is equal to 0, we can solve this equation to find x. So I'm going to add 9 to both sides of the equation, so 2x is equal to 9. Then if I divide both sides by 2, I find that x is equal to 4.5. So there's one value of x. Or this bracket here is equal to 0. So x plus 2 equals 0. So the other value of x must be negative 2. Okay, so if we look back at the diagram, we can see that the x-coordinate of point A has to be negative, so that would be this one here. Okay, so at point A, x is negative 2, and so at point C, x should be 4.5. And remember, the y values are both 0. In part B, we have to differentiate 18 plus 5x minus 2x squared, which is from the equation of the curve. So remember, when you differentiate a constant, okay, so a number without x, this will go to 0. If you differentiate positive 5x, it's the same thing as 5x to the power of 1. And so remember, when you're differentiating, you're taking the power, so 1, multiplying it by the number here, so 1 times 5 is 5. And then the power on the x decreases by 1, which would leave you with x to the power of 0, except anything to the power of 0 is equal to 1. Okay, so this is the same thing as 1, and 5 times 1 is just 5, so you don't actually need to write that part down. Okay, then if we differentiate this term here, I'm taking the power here, so positive 2, multiplying it with negative 2, which is negative 4. And again, decreasing the power on the x by 1. So 2 take away 1 is 1. So it's like x to the power of 1, except usually we would just leave it as x. Now in part C, we have to find the coordinates of the point on the curve where the gradient is 17. Now remember, when you differentiate the equation of the curve, remember this is what we did in part B, you're finding an expression for the gradient of the curve at any point. Okay, so this is the gradient of the curve. In part C, they tell us the gradient is 17. So what you can do is put your expression for the gradient, so 5 minus 4x, equal to positive 17, as we know this is true. Now, if you solve this equation, you're finding the x-coordinate of that point. Okay, so you're halfway there. So let's solve this equation. So I'm going to subtract 5 on both sides. So I have negative 4x is equal to 12. And then if I divide both sides by negative 4, I find that x is equal to negative 3. So there is the x-coordinate of the point in part C. So all that's left to do now is to work out the corresponding y value, and just like we were doing earlier, we're taking the x-coordinate and substituting it back into the original equation, in this case to find y, okay? So I'm just going to write out the equation again, so y equals 18 plus 5x minus 2x squared, and I'm replacing those x values here with negative 3, okay? So y is equal to 18 plus 5 multiplied by negative 3, take away 2 multiplied by negative 3 squared. And then if you calculate this, you should find that y is equal to negative 15. Okay, so there's our y coordinate. So the coordinates of the point on our curve when the gradient is 17 would be negative 3, negative 15.